All right, this is going to be our first lesson on trigonometry. This is 12.1 trigonometric ratios. So let's do a couple of definitions. What is trigonometry? Okay, trigonometry is the study of the relationships of the angles and the sides of triangles. Okay, most specifically, we're going to just focus on the right triangles, but it is of any type of triangle. Trig ratios, when you hear me say that, trig obviously being short for trigonometry, this is going to be the ratio of the lengths of two sides of a right triangle. Okay, and again, it can be for any triangle, but we're going to mainly focus on right triangles. And so what is a ratio? Another word for a ratio, in case you forgot what a ratio is, it can be something like x over y. Okay, that's a ratio, which can also be written x is to y, but we're gonna leave it in fraction form. Okay, so we're gonna be writing some fractions because we're gonna be writing out some ratios. And so then the three basic trig functions that we are going to use are going to be sine, which for short you'll see it as this, S-I-N. Okay. And then our second one is cosine, which for short is going to be COS. And then the last one is tangent, which is going to be TAN, okay? So the abbreviations are what you see on the calculator, and you probably have noticed them one time before. So we're going to use those right there. Those are our trig functions. So they all have a specific ratio, okay? But there's some terminology that we need to use, especially when we focus on an angle. So when we're going to focus on, let's say, the first triangle over here, we're looking at angle A. See how it has a star in angle A? Obviously, this side you guys know to be the hypotenuse, okay? So that's always going to be referred to as a hypotenuse. Now, this side right here, side AC, which is right next to angle A, this is going to be the adjacent side. Adjacent. And then this side over here away from it is going to be your opposite side. So when we're referring to this angle A, this side BC is going to be the opposite side, this one's going to be the adjacent side, and this one's going to be the hypotenuse, okay? Now we also can refer to the other angle B over here, okay? So angle B has a star in it. This one is still going to be your hypotenuse. This side right here, BC, is right next to the angle B, so that's now going to be our adjacent side, which before over here, the BC was the opposite side. So it always depends on which angle you're working with. And so now AC over here, since it's away from it over here, this is going to be our opposite side. Okay? So you have to be able to label those correctly. Hypotenuse didn't change, but sometimes the opposite and the adjacent change depending on which angle you're talking about. Okay? Notice I didn't say anything about angle C. We will never use the right angle. Only the two acute angles, either A or B. Okay? And again, sometimes they're labeled a different letter. These ratios were created a while back by a mathematician, of course. Okay? And so here's how the ratio goes. The sine, okay, which we wrote down earlier, the sine of angle A is always going to be the ratio of this, the opposite side over the hypotenuse. And so for short, this one right here is an easy way to write it, opposite over hypotenuse, okay? The cosine ratio, cosine of angle A, okay, this is going to be the adjacent side over the hypotenuse. So here's an abbreviation for that. And the tangent ratio, this trig function, also known as that, is going to be the opposite side and over the adjacent side. So opposite over adjacent, okay? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and that's just the way these rules go. These are on your formula chart, and again, you can always use your notes, so you should always refer to these whenever we're writing out these ratios, because that's what we're going to do here in a minute. We're going to practice writing out the ratios. An acronym that a lot of my students like to use in the past is called this right here. SOH, so, TOA, okay? SOH stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, okay? And so a lot of my students, well, really, we used this acronym way back when students had to memorize these formulas. You guys have it on your formula chart now, so you don't have to memorize it. However, I find that my students use this and write this down on their homework paper instead of having to refer back to the notes. So they'll write it at the top of their paper still to this day. Okay, so let's practice writing out ratios. Okay, so they put letters on each one, so we're going to practice writing that. So sine of A, so here's angle A right here. I'm going to use purple to kind of work with this, just kind of underline it in purple. So if this is my angle A, these are all these in the first column. Sine of A would be, remember, opposite over hypotenuse. So this is going to be little a over c, little c. And cosine of A, and again, writing this out at the top so you don't have to refer back to it helps remember the order of the ratio. So cosine is A over H. Okay, so adjacent over hypotenuse. Also, it's also good to write down labeling the hypotenuse, because a lot of people think the hypotenuse is always over here because most of the time the right triangles are drawn like that. But when you twist and turn the triangle, it can get a little bit challenging. So remember, this is your hypotenuse down here always. So cosine of A is adjacent over hypotenuse, so this is going to be little b over c. And then remember, tangent of A is opposite over adjacent, so I'm going to go opposite over adjacent. So little a over little b. Sine of B, let's try sine of B. Now I'm going to use a different color just to kind of make sure we realize it goes over here. So here's B over here now. So I'm going to put a little star in this angle. So remember, sine is opposite over hypotenuse. So the opposite of angle B is little b over hypotenuse is c. So b, little b over little c. Cosine of B is adjacent over hypotenuse. So a over c, little a over little c. And tangent of B, remember, is opposite over adjacent, b over a. Okay, so that's just practicing writing out the ratios. Let's try it again, but with actual numbers, because this is what we're actually going to use in some problems. So it says write the ratio of each trig function as a reduced fraction and as a decimal to 3 places. Let me go get my calculator. Okay, so we're going to write each trig function ratio according to each one. So remember, I like to see the acronym, so I'm going to write it down so that way I can refer back. I mean, I have it memorized by now, but we don't all have it memorized, so it's always good to look at the acronym to see and just be sure that you write each one. So remember, sine is opposite over hypotenuse. And so remember, this is for angle X. So you want to make sure you look at angle X. I'll put a little red dot right here. And so opposite over hypotenuse. Well, there's nothing on the hypotenuse. So what should we write for that? Just leave it blank? Absolutely not. You should know what to do when you have 2 out of 3 sides of a right triangle and how to get that. And that's called Pythagorean theorem. So I'm going to put 12 squared plus 5 squared, which is 25. And then I'm going to square root that. So 13 is actually this side right here. It's a nice, pretty whole number. That's a triple. So remember, opposite over hypotenuse, 12 over 13. So I'm going to write 12 over 13. And when you write the ratio as a fraction, all you're doing in the calculator, guys, is putting 12 divided by 13. And it says to round to 3 places. So you can practice that and pause this video if you want. Get your calculator and do 12 divided by 13 and practice rounding. Believe it or not, some of my students always forget how to round. It's 0.92307. So the fourth one is a 0. So It's 0.923. Okay, let's go to the next one. All of these are x, so I'm going to focus and do this first column first. I'll do the second column second. So this is cosine of x. So remember, cosine is adjacent over hypotenuse, adjacent 5 over 13. So 5 over 13. And 5 divided by 13 is 0.3846. 0.3846, but remember the 6 rounds the 4 up, so it's going to become a 5. Okay, let's go to tangent of x. Opposite over adjacent, so 12 over 5. 12 divided by 5 is 2.4. Okay, so now we're turning these ratios into actual values, okay, when we have side lengths. All right, let's go to the other one now, the other column. This one's focusing all on angle y, so I'm going to use a different color. So y is over here, so I'm just going to put a little blue dot over here. And so sine of y, remember sine is opposite over hypotenuse, so the opposite is 5 over 13. Now remember, you might have done this ratio over here, so you can use that same decimal rather than having to punch it into the calculator again. So this one was 0.385. Cosine of y is adjacent over hypotenuse, so this one's 12 over 13, which we did that up at the top, so 0.923. And tangent of y is opposite over adjacent, so 5 over 12. We haven't done that ratio yet, so I'm going to put 5 divided by 12 in my calculator, and it's 0.41666667, so repeating. So I'm going to write 0.4167. Now, some of y'all might say, well, what if I write 0.4166 with a bar over that? That's fine too, okay? All right, so writing ratios with actual values, that's the next step. So hopefully you're getting real comfortable using these ratios, SOHCAHTOA, TOA, and writing them out, because that's what we're going to do to actually solve problems. Okay, let's go to the next page. So we're going to have to be using the 3 trig functions in our calculator. And so we're going to practice right now using our calculator to do that. And we're going to round to 4 places. So what needs to happen though, is, and I want you to write this down, your calculator must be in degree mode. Now I understand most of us are probably using our iPhone, so I put that here, a picture of your iPhone. And when you turn it sideways, you want to focus on this button right here, okay? And you do not want it to say RAD. That stands for radian, okay? You can say rad for short, but it stands for radian. We don't want it in radian mode. So you want to make this disappear and go away, you need to press this button down here, and it says DEG, so you're pressing degree and it gets removed. So you don't want anything to be showing right there, okay? So let's practice that. We're going to press sine 42 in our calculator. Now the weird thing about the iPhone calculator is you're going to actually do it backwards. Now if you have a TI Inspire, you actually press sine first and then 42, okay? Or a fancy calculator on the internet, you actually do it that way. But if you're using your iPhone calculator, I'm pressing right now, I'm pressing 4, 2, and then I'm going to press sine, which is right there, okay? So 4, 2, and then I'm going to hit sine. And it should be a decimal, so it's going to be 0.6691. 6691. So that is the decimal of sine of 42 degrees. Okay, so remember, we're going to be using angle degree measures. So let's try cosine of 15. Now remember, I'm going to press 15 and then hit cosine function. So this one you should have got 0.9659. Okay, so that is the decimal equivalency of cosine of 15 degrees. And lastly, let's try tan of 67. Now, if you're not getting these values, it's probably because you're not in degree mode. So you need to make sure you press degree mode. All right, so I'm going to press 67 and then the tangent button, and you should have gotten 2.0 3, 5, 5, 8, 5. So that means the 8 goes next to a 9. Okay. So that's just practicing punching the sine, cosine, and tangent function on your calculator. All right, so these are what the real problems look like. So all of that is leading up to this. And so here's what a real problem is going to look like on your homework and on your quiz coming up at the end of the week. It's going to have at least one angle measure that they give you, and at least one side. And then you're going to have to solve for the other sides and possibly the other angle. But the other angle is easy. That's just the 180 rule. So you notice you cannot use Pythagorean theorem because you don't have enough sides. And you cannot use any special right triangle because it's not 30, 60, or 45. This is where you're going to use your trig function. So let's focus on finding A first. It has A. So A, and you want to put a little star. This is the angle that they gave us, 36. Okay, so it's kind of like what we did earlier. The A is opposite of the angle. The 10 that they gave us, because you have to use what's given, is your hypotenuse. Okay, so remember what goes with opposite and hypotenuse. So if I write my little, oops, wrong one. So the TOA, O and H, see opposite and hypotenuse? I'm using this trig function right here, okay? So I'm gonna write down sine of 36 degrees because we know the angle measure now. We're not writing a letter. Equals the ratio, little a over 10. Okay, so now how do you solve for little a? Well, the original way to do this is imagine putting this over 1 and it's like a proportion. So you're going to cross multiply here. Okay, 1 times a is a, and then 10 times sine of 36 goes on the opposite side. So this one's the easy one when the variable's on top, okay? And so a equals 10 times sine. So I get to just punch this into my calculator now. So 10 times, remember you have to press the degrees first, 36 sine, and then hit equals. And so little a is equal to 5 point, what are we rounding to? 3 places, 878. Okay, so A is 5.878. Okay, so that is one side that we've solved for. Again, this is all based off of the degrees of the angles and the length of that hypotenuse. And these trig functions is what's used to help solve for that. So 5.878. And so now we're going to solve for B. Okay, I'm going to pick a different color so we can see what it looks like. So B is the adjacent side. So I'm going to put a little A next to that, or adjacent. That's adjacent next to the angle. And I'm going to still use the hypotenuse because it's a pretty simple whole number of 10. Okay, so I'm going to write that down. What uses adjacent and hypotenuse? This one here, cosine. So I'm going to write cosine of 36 degrees equals little b over 10. Okay, so remember the variable is on top, so all I do with these two is multiply because that's what I did over here. So if you want to put it over 1, you can do it the long way. 1 times b is b, and then 10 times cosine of 36 goes on the other side, which we'll just punch that into our calculator. Okay, but you'll get quick at this and realize, hey, the variable's on top, so all I do is multiply those two. So we're going to press 10 times 36 cosine and then hit equals. Don't forget the equals. So this is roughly 8.09, and then it's 0.1, but you don't need to write the 0.1 unless you really want to, but we're only rounding to 3 places. So 8.09. Okay, and there's no units on here, so you can just leave it as is. Okay, but sometimes if it says centimeters or inches, you'll write that. And that's how you solve for the sides. You're using these trig functions to solve for those sides. So let's try this next one. So I have this 70-degree angle right here, okay? I have the 9, which is opposite of that angle, okay? And so if I want to solve for C first, okay, well, A comes first, so let's go ahead and solve for A. This is the hypotenuse. So what uses opposite and hypotenuse? Right here, O and H, sine. So I'm going to use my sine function. So I'm going to say sine of 70 degrees equals opposite 9 over little a. Okay, so 9 over a. Now this one's different. You'll notice the variable's on the bottom. So we're going to do something different. Think about it. If we multiplied over here, what do you think we're going to do over here? We're going to divide. So I'm going to show you the long way, and then we'll do the short way first. So if I put this over 1, I'm going to cross multiply. 9 times 1 is 9. And then I have over here sine of 70 times a. A times sine of 70 degrees. So if I want to get a by itself, that's some room. So this is the hypotenuse. So if I want to get a by itself, think about algebraically, what would you do to get a by itself? Well, you would divide by sine of 70 to cancel that out, and whatever you do to one side, you must do to the other. So a is equal to whatever 9 divided by sine of 70. See how we're dividing over here because the variable was on bottom? Over here, the variable was on the top of the ratio, so we multiplied. Okay, so you'll get quick at this and you can just do that and you don't have to show all this work right here. So a is equal to whatever 9 divided by sine of 70 degrees is. So let's try that in our calculator. Follow along with me. 9 divided by 70 sine, and then hit equals. So A, we should have got 9.578. It's 775, but the 5 rounded up. So 9.578. Okay, so that's our answer for A. So now let's find C. Okay, let me get a different color. So C is adjacent. Okay, so that's adjacent to the 70 degrees. And I'm going to still use this one over here, the nice simple whole number. Now, let me also remind you, you can use, since you already solved for A, you can use Pythagorean theorem if y'all want to. Okay, but for the purpose of this notes in practice, we're going to use another trig function. So what uses opposite and adjacent? Right here, the tangent function. So I'm going to write tangent of 70 degrees equals opposite over adjacent. Okay, so the variables on the bottom. Think about, what did we do? I'm going to box this. What did we do when the variable was on the bottom over here? We ended up pressing 9 divided by sine of 70. So that's what I'm going to do here, 9 divided by tan of 70. So C is equal to 9 divided by tangent of 70 degrees. So I'm going to, let me fix that. I don't like the way that looks. So I'm going to divide that in my calculator now, and that's what's going to be my C. So I'm going to hit 9. And I'm using the iPhone calculator since most of y'all have that. I'm pressing 9 divided by 70 tan equals. So C is equal to 3.276. 276. And that's my side C. 3.276. Okay. All right, so that's what some problems look like. And again, you don't have to show all this work once you get used to it's either multiplying or dividing. All right, let's do the last 2 problems of the day, which are related to area. All right, so if I'm having to find the area of this triangle, most of you guys know that it's base times height divided by 2. That's my area formula. And so I know the base here but I don't know the height. And I have to know the height in order to find the area. So what you need to focus on is, you need to focus on, let me get my highlighter. You need to focus on this right here. What did I just highlight? I just highlighted a right triangle. And if you know an angle measure, which was 40 degrees right here in this corner, angle B, and you're searching for H, which is opposite of that, and you know the hypotenuse, then you should be able to solve for that H, which then we can use our formula. So what is, this is, I'm going to put a little O for opposite. Opposite the the BC side, which is the 100, which is what is given, is the hypotenuse. So what uses the opposite and hypotenuse? So again, remember writing, oops, I'm not even writing it right. Writing TOA at the top of your paper kind of helps the remembering those formulas. So here it is right here, opposite and hypotenuse. So I'm going to use sine of 40 degrees equals opposite, which is H, over hypotenuse. Okay, so remember the variables on top. So what do we have to do to punch to get the value of H? If the variable's on top, all we do is multiply these two. So in your calculator, I'm going to multiply 100 times sine of 40 degrees. And that's going to equal my H. So let me get my calculator. Turn it sideways. I'm going to put 100 times 40 sine equals. Don't forget to hit the equals. So that H is roughly about 64 point, it didn't say what to round to, but what did we round to on all of the other ones? About 3 places, right? So let's just go 3 again. 279. Okay, so let me just double check my work. Okay, so the height is 100 times 40 sine equals, yes, so 64.279. All right, so there's my H. So now I can punch it into the area formula. So base is 150. So 150 times 64.279 divided by 2. And that's going to be my area over here. So I already have that long number, 64.27876096865, a long number in my calculator still. So I'm going to leave that there, and I'm going to hit times 150 equals, and then now I'm going to hit divide by 2. So the area of this triangle is roughly 4,820.907. And this is in meters, so I'm going to hit meters squared. Okay, so let's write it down. Final answer, 4,820.907 square meters. Okay, that's the area of the triangle. Let's try it one last time. This one, they didn't draw the height for us, so we got to figure out how to draw in this height. So what I want to do is think about how you can make a right triangle, okay? Think about how you can make a right triangle. So a lot of people want to do, you know, here it is right here. There's my right triangle, okay? But you don't know this to be your base, and we can't solve for it either, okay? There probably is a longer way to solve for it, but we're not going to draw it this way. We want to kind of draw it inside the triangle, okay? So how about if I draw it like this from here to here, put my right angle here, and do you see that right triangle? So I'm going to outline that. Here's my right triangle that I can use. So if I find this height right here, I'm going to label that H, where's the base? That means this over here is your base, which we know what it is. It's 84 feet. Okay, so remember, your base doesn't always have to be at the bottom like this problem on the left, and that's what most students have a hard time with, which is why I added it to the notes this year. So this is our base, this is our height. We can solve for it by using the 41 and this 57 right here. Okay, so the 57 to the 41, that is our hypotenuse. And this one over here is our opposite side because it's away from the 41. So what am I using again? I'm using that sine function again. So I'm going to hit sine of 41 degrees equals opposite over hypotenuse. The variable's on top again, so what am I going to do with these two? Same thing that I did over here, and that was multiply those two. So you're going to punch in your calculator. 57 times sine of 41 degrees, and that's going to equal my height. So let me punch that into my calculator. 57 times 41 sine equals, don't forget the equals. So the height of this triangle is about 37.395. 37.395 feet. All right, so now I can put that into my area formula, which is base times height divided by 2. So the base is 84 times 37.395 divided by 2. Remember, that's our area formula. So I have that long number in my calculator still, so I'm going to just press times 84 equals a big number divided by 2. And so our area is roughly 1,570.605 square feet, because this is area. So you did area of triangles in middle school, and we did a little bit this year so far, so you should be comfortable with finding the area of triangles. But we do have to use this trig function in order to find the height. So 1,070.605 square feet. So you'll have some problems like that on your homework.